الشيطان الرجيم بسم الله الرحمن الرحيم وصلى الله على سيدنا محمد. أما بعد, Assalamu alaikum wa rahmatullahi wa barakatuh. My name, as you know, Suleiman Muhammad Al-Masi, your usual chemistry master. Alhamdulillah, the class we are about to take is SS3 class, and from the topic we are treating before the unfortunate break we had, we were looking at energetics, or you see, energy and chemical reaction. So before we vacated, we started looking at the definition of energetics, which we said it is the science of chemical reaction and the related energy and the associated energy released. Under this, we looked at enthalpy. We also look at enthalpy change. Enthalpy, which is represented with letter H. Then we have enthalpy change, which is represented with delta H. All these we have given the definition in our previous class. So the next thing, under enthalpy change, we said we have two types of reaction: endothermic reaction and exothermic reaction. Endothermic reaction, we said it is a type of reaction that has to do with the absorption of energy or heat from the environment, and eventually leading to coldness of the environment. Then we said exothermic reaction is a type of reaction that lead to the release of energy into the what? Into the environment, and eventually the environment becomes hot, or the temperature is rising. So we use some sketch from the note we had to actually illustrate how endothermic and exothermic reactions are determined. So here I just want to quickly refresh your memory, even though we have it in the note already, before we now move to the next thing. So this is a sketch that can be used to illustrate both endothermic and exothermic reaction. And as we know, and just like we have been informed, the first thing you are supposed to know is actually to know how to draw correctly the sketch that is depicting this reaction. So there are things you must note, which is very, very important. In case of examination, definitely some of these things are things we are going to take note of. You must have your axis, the energy axis, and the reaction coordinate. For the energy axis, we said you have your energy with the unit as joules. Then we have the reaction coordinate, or you said reaction path. So on the energy, we have values that are usually given, which are supposed to place on the axis. This is the origin, then you have your values. So like this one I'm using, we have 3, 6, 9, 12, 15, 18, and so on. So on the sketch, you have the reactant, and you also have the product. This is the product axis. You have the activated complex, that is the peak of the reaction. Then you also have what we call the activation energy. This is the enthalpy change. So now, if you want to calculate endothermic reaction, we know the formula is change in enthalpy equal to heat of product minus heat of reactant. Now if you look at what we have on the board, if this is the reactant and this is the product, you can now see that your product now, if you trace it to the value, you can assume that this is, the product is at the point of what? 12. And that is how we're having 12 here. So also for the reactant, if you trace it, you see that the reactant axis is on what? It's on the value 9, and that's how we're having 9. So if you minus it, 12 minus 9, you are going to be having plus 3. So under normal circumstance, for endothermic reaction, the value is supposed to be positively what? It's supposed to be a positive value, while endothermic reaction is supposed to be a negative value. So whenever you are making your calculation, you are determining endothermic reaction or exothermic reaction. Let's say you are determining that of endothermic and your value is not positive, you should know that you are very wrong. There is problem somewhere. Likewise, if you are determining exothermic reaction, the reaction is supposed to be negative. If it's not, that means there is what? There is a problem. So now that is for endothermic reaction. Now for exothermic reaction, you have your enthalpy change, heat of product, heat of reactant. Now if we look at our sketch, here you need to change it, you need to change the sketch so that you now have what you are looking for, which is an exothermic what? Reaction, and the value is supposed to be negative. Now how do we do that using this? I'm not going to change the sketch, but I'm just going to explain to you, which you are supposed to practice it at your leisure time. So what you just need to do is that you bring this product sketch, product axis, you bring it down. Let's assume to this point 3. For this one, you draw it down like this to point 3 here. You leave your reactant the way it is. Now if you take the difference, you see that from the formula, heat of product, if you look at the value, it's going to be 3. Heat of reactant, the value is going to be 9 the way it is here. So if you take the difference, it's going to give you minus 6. This is telling you that this reaction is an exothermic what? Reaction. And just like I've said earlier, if it is not giving you minus, that means definitely there is what? There is a problem. So the last part of this is how to determine the activation energy. Activation energy. So in determining the activation energy, it also have a formula, and the formula is activated complex minus heat of reactant. When we say activated complex, we mean the peak of the reaction. And if you look at the peak of the reaction here, you can assume that it is what? It is at point 18 here. The energy is 18. So if you take it, you have 18 minus heat of reactant, which is here. So 18 minus 9 is going to give you plus 10. So this is how to determine both endothermic, exothermic, and activated complex.